Alright, talk about scientific notation next, and in order to understand scientific notation we have to look at powers of 10. And you can see here on the table we have common powers of 10, like 10 to the third is 1,000 because 10 times 10 times 10 is 1,000. 10 to the second is 100 because 10 times 10 is 100. And we keep moving on down the line to 10 to the 0, which is 1, because anything to the 0 power is 1, which we learned. And on to 10 to the negative first, which is the same thing as 1 over 10 to the positive first. We move that to where the exponent is happy. If it's not happy where it's at, we move it to the opposite place. Same thing with 10 to the negative second. It's happy in the denominator, so that's like 1 over 10 to the positive 2, which is 1 over 100. And then you can see the decimals that go along with these as well. So 1/100th is 0.01. And then all of these do have decimals, you just don't see them. And as we move to the right, you can see that the decimal place moves 1 spot to the left. And vice versa, that's because we're dividing by 10 each time we move down the line to the right. As we move to the left, the decimal place moves 1 spot to the right instead. And we're going to use that knowledge to help us out with scientific notation. Alright, so you can always start with 1, okay? So 1 times anything doesn't change anything. And whenever, this only works with powers of 10, but when you have a positive power of 10, you can move your decimal spot to the right. When you have a negative power of 10, you move your decimal spot to the left. So here's what this looks like. You always start with 1, so I could rewrite this as 1 times 10 to the negative third power. So just a side note here, we know that 10 to the negative third is the same as 1 over 10 to the positive third, which is 1 over 10 times 10 times 10, which is 1 over 1,000, which equals 0.001, okay? But here's how we can do that using this. My decimal is at 1.0, and it's to the negative third power, so I can move that 1, 2, 3 spots to the left and fill in those little spots, and we get 0.001. That's how we can take that shortcut. 10 to the second, you know 10 times 10 is 100, but just to prove the point here, since it's to the positive second, I can move that decimal 1, 2 spots to the right, fill that, and we get 100. Alright? And there we go. And if you ever see 10 to the 0, that's like 1 times 10 to the 0, okay? And you're moving your decimal 0 spots. So 1.0, just like that, alright? So that's how that works. And scientific notation is the next thing that we'll talk about, and this leads us into that. If you have any wacky numbers times powers of 10, you can take your 97.86. If you're multiplying by 10 to the 6th power, you just move your decimal spot 6 spots over to the right. So 1, 2, 3, 4, 5, 6. And then these become placeholders for 0. And this is the number that you're looking at. A pretty large number, 97,860,000. The opposite is true when you have a negative power of 10. We take our decimal and we move it 4 spots to the left. 1, 2, 3, 4, and we get 0.00195. Alright? Now, scientific notation is just a very specific way to write very large or very small numbers. So the specifics of this are that the first number is greater than or equal to 1 and less than 10. So this first number always has to be less than 10, but 1 or greater. And that's something we'll talk about in class, but that's just the way it is. So scientific notation will always be set up like this. Some number with a decimal times something to the 10th, basically. And it can be negative, positive, maybe it's not even a decimal, but you know, as long as it's less than 10, it's okay. So what does this look like? So real quick, last example. We have Jupiter, 143,000 kilometers is its diameter. Shortest distance from Earth is this 5.91 times 10 to the 8th. They want us to take that shortest distance and write it in standard form. That just means write it as a number. So 5.91 times 10 to the 8th power. We just take our decimal and we move it 8 spots to the right. So 1, 2, 3, 4, 5, 6, 7, 8. And you can see we have a very large number for kilometers there. And then we take the average distance to the sun, which is this number right here, and we can write this in scientific notation. All we have to do is work backwards. So 7, 7, 8, 4, bunch of zeros. Okay, so I'm going to write 7.784, because remember that first number has to be less than 10 or 1 or greater. I'm going to figure out how many spots it takes me to get to the end here. So 1, 2, 3, 4, 5, 6, 7, 8. And there's that number in scientific notation. Alright, that's all I've got for you. We'll cover more of this tomorrow.